We are Sweden's largest price comparison website. We've been awarded the best price comparison site in 12, 13 and 15 by Internet World. We operate in 5 countries, known in Sweden and Norway as Prisjakt, and in New Zealand, United Kingdom and Ireland as PriceSpy. We are currently staffed by almost 130 employees in 4 offices in Ängelholm, Stockholm, Krakow in Poland, and Oslo. We're looking into opening an office here in Malmö as well. If you've ever used one of our services, this may look familiar to you. On the left, you have our desktop website, and on the right is our iOS app, which we're quite proud of. Let's talk a bit about the background of PriceSpy now.
Prisjakt was started in the early 2000s by Jonas Birgander. It was a hobby project at first, and everything was hard-coded for the Swedish market. It was built with the classic LAMP stack, Linux, Apache, PHP, and MySQL. And it was using Western European character encoding, Latin 1, because Unicode wasn't really a thing in PHP back then. In 2009, we launched a site in New Zealand. We bought an existing site and replaced it with our own. So we had to consider things like internationalization, localization, translation, formatting dates, formatting numbers, stuff like that. We also had to sync data from Sweden to New Zealand and the other way around, because we want data from Sweden to flow to New Zealand, because the latency from Sweden to New Zealand is around 300 milliseconds when it's good. Sometimes it's down completely. So we have to have local servers in New Zealand and sync data to them. New Zealand, the PriceSpy in New Zealand is a very tech-focused site, so we needed a dynamic category hierarchy. We needed to expose more tech categories on the front page. We also needed to make product names editable, because I have an example of a Canon camera, EOS 450D. It's also called Rebel XSI and KISS X2 Digital in different markets, so we need to account for that. Not all features from the Swedish site should be available in other markets either. We have things like cell phone contract comparison, which we don't want in New Zealand, at least not from the beginning. So we need to sync product data and all other data from Sweden to New Zealand. That brings us to database syncing.
And the way we go about syncing, to give you a brief overview, is that we dump filtered data from our global master database. And by filtered, I mean that we exclude things that we don't want in the target market. So countries that are not sold in New Zealand are not dumped when we're exporting data for New Zealand. We run various scripts to transform the data to fit the target market. I'll get back to that in a moment. Then we calculate the differences against the target market's database and dump those differences to a variety of files, which we then transfer to the server and import straight onto live. The server I could mention could be on the other side of the world, or it could be in the same data center. Our system can handle both just fine. The sorts of data transformations we do involve updating columns with translated values, where, for instance, we store the category name directly inside the category table, as opposed to looking it up through a separate translation table. So when we're exporting things to New Zealand, we need to translate all the category names. We sometimes need to modify product names, because they may contain colors that work fine in Swedish, but not so good in New Zealand, because they don't know what blå is. They might be able to guess. We also sometimes need to translate commas to dots in numbers, for instance, in product names again. Some products need to be translated entirely. As an example, we have a Lego set, which in Sweden is called Elsas gnistrande islott. I don't think a New Zealander would be able to find that, so we have to translate it to Elsa's Sparkling Ice Castle. And we calculate things like the lowest price for products and the lowest price in stock. We have to recalculate the popularity of products and categories and the variety of other things. And of course, we have to generate metadata for product properties. For instance, the smallest and largest size that a TV can have, which is of course dependent on what kinds of TVs are available in the country. To accomplish all of these things, we have built our own tools. They've been working really well for a very long time, large number of years, but it's starting to get a bit slower as the database size increases, because we have some seriously huge tables, talking billions of rows here, where the old rows almost never change, and calculating a diff against these is really expensive. We have considered using MySQL's replication for this, but the problem there is that there is no way to filter. You cannot say, I want rows matching this condition. You either get the entire table or nothing. So that's not an option, really. The solution we've come up with is to start using message queues. We've chosen to go with RabbitMQ, which is a very robust and very reliable implementation of AMQP, the Advanced Message Queuing Protocol. And it's been quite a lot of work to implement this on top of the existing synchronization system, but we've managed to move one table from sync to RabbitMQ, and it's improved the sync time immensely. United Kingdom sync has gone down from almost 3 hours to just under 1 hour. To illustrate this, here is a graph of the average sync times before and after RabbitMQ. That big drop there is the result of moving one huge table over to a message queuing system. And now that we've figured out how to synchronize data to other countries, we need to be able to show the right features per market, which brings us to
feature flags. Feature flags allow us to enable or disable a certain feature for a specific market or a specific user group or a combination of the two. So, a concrete example is a mapping system. In Sweden, we use an API from hitta.se. In all the other markets, we use Google Maps. So we need to enable Hitta for Sweden, disable it for all the rest. And it works very good. We're storing the settings in a database and then use memcache to cache them for fast lookups. And here's an example of how it looks in the code when you use the feature flags. The example at the top is for PHP and JavaScript, and in this case they look identical. And on the bottom you can see Smarty templates, which is a templating engine for PHP that we use. I missed something. Go on.
You missed the transition?
Yeah.
No. So we have a way of showing the right data, but we also need to show it in the right way, which is where we get to localization. For Prisjakt, the three major challenges that we have to show, things that we have to show correctly, are numbers, prices, and dates. And the formatting rules for all of these can differ quite widely between markets. For numbers, there are three primary questions you have to answer. Namely, what thousand separator does the country use? Do they use a comma, a dot, a space, something else entirely? Do they even use a thousand separator? Some countries group digits in pairs. Some do every 4 digits. Some have even more complicated systems. You have to figure out what decimal mark to use. There is approximately a 50-50 split between comma and dot, but some Arabic countries use their own system altogether. And of course we have ordinal numbers, first, second, and third. What are the rules for making those? The rules can be quite complicated. It's rarely as simple as just adding a dot, though some languages are thankfully that simple. And that's another thing you really have to figure out if you want your users to be happy. To solve these issues, we have written our own little functions. Here are some examples of number formatting functions in PHP, in JavaScript, and in Smarty. 1000 is a bit of an unfortunate name. It's Swedish for 1,000, but it works. It does the trick. And all of these functions read their settings, all the formatting rules, from our configuration, so it's easy to change depending on the market. For ordinal suffixes, there we go, we have our own little ordinal suffix function, which chooses a function based on the language. For Swedish, we have this sample function here, where if the number is 1 or 2, we append an A, otherwise it's an E. But there's actually a little bug in here, which we discovered while planning the presentation. Because in Swedish, the rule is you're supposed to use A when the number ends in 1 or 2, but not 11 or 12. And we'll tell you in a moment how to avoid little problems like this. But first, there we go.
Prices, because we're a price comparison site. We display a lot of prices. And the rules for formatting prices, they vary wildly between countries. And the rules aren't the same as for normal numbers, not all the time anyway. And some countries use a currency symbol, some use an abbreviation. Like in Swedish, we have KR for kronor. The 1000 separated can be different when you're displaying prices instead of normal numbers. And on the bottom you can see examples from our 5 current sites: Swedish, Norwegian, New Zealand, Great Britain, and Ireland. And of course we made functions for this as well. Dates, next up. There are many different ways to represent a date in text. On the second bullet you'll see 3 different text representations for the same date. And different users in different markets will expect one of these or another. There are many different ways to format it. And we use ISO 8861 everywhere, and it works fine so far, but we'll have to change it in the future. Another thing to consider are time zones, because some countries are in multiple time zones, but all of our current markets are in a single time zone, so we haven't really tackled it yet. But ideally, you should store all times in UTC and then convert them for display. If you're using PHP, you should probably just use the Intel package, because it has formatters for you. You don't have to do it yourself. We've tried to do it ourselves, but as you saw, there are bugs. It's easy to miss things, and even in our native language, Swedish, we miss things. So use packages. There are packages available for all languages and most frameworks as well. Okay, we can display the data, but we need to translate our messages as well. We need translations. In the beginning, Prisjakt was a Swedish-only site. Everything was hard-coded. So when we were about to launch in New Zealand, we had to create a tool for it, and we had to go through all files and tag translations or convert them to function calls to translate functions. We created our own tool called PTM, and it stands for Prisjakt Text Management or Prisjakt Translation Management. We're not sure anymore. We only call it PTM. I tried to grep it in the source code, but I couldn't find anything other than PTM. So we were afraid of the performance when doing thousands of translation calls per page request. So we added a compilation step for templates. So we pre-compiled templates and just replaced translations in place inside the templates. But today we use getText instead for most of these things, and we still use some parts of PTM, but that's mainly for the database translations. And PTM, it was fast, but not very flexible. It had no idea what the plural was, so we had to hard code all plural rules, and they worked fine for Swedish, Norwegian, and English. But if we want to enter another market, they would not work. Another problem with this is that we created 3 different translations for each pluralized string. So it was a hassle for the translators. And we had to create our own tools and maintain them as well, and that's not very nice. So we started using getText instead. It was released in 1995. It's a part of the GNU project, and bindings exist for most languages. The really neat thing with getText is that the plural rules are inside the translation files. The translator will specify the plural rules, and they are experts in the language, so that's very nice.
But the way in which we use getText is slightly different from how many other companies use getText. The first thing we decided we needed to do was to add support for named parameters. So you can see this %product name thing here. That's a named parameter that we later replace with actual values. Normally you use positional parameters, which is really problematic when you have more than one, partly because word order varies a lot between languages. You never quite know what order you'll get things in. And it's difficult for translators because they have to keep track of which placeholder is what. So named parameters were definitely a necessity. We also use keys like product.title.details rather than the entire original phrase as the message identifier, because there are a lot of ambiguous words. For example, the English word run can be used in meanings like to run a program, run a marathon, running water, and about 100 other different meanings, which may all have different words in other languages. So using keys also becomes quite necessary when you're dealing with large amounts of translations. This latter thing has become a little bit of an issue at times because a lot of getText tools expect you to use sentences as message IDs. So translators don't always get the right context when they're translating. On the other hand, it's allowed us to separate translations into multiple packages. Since we have quite a lot of translation strings, over 3,000 in fact, being able to separate them into multiple packages allows us to load only the things we need for each request, rather than loading everything all the time, which is especially important when you consider that a PHP request loads a new PHP process each time. It's basically like starting from fresh. So packages are great if you are concerned with performance and memory use. Of course, our translation system is accessible through PHP, the regular translation up there, a pluralized translation, and a replacement of placeholders, nothing too special. We can do basically the same thing in JavaScript, where we use the lovely GED library, which is a getText-like JavaScript package, which allows us to compile our getText files to JSON, so you can use it exactly as you would in PHP.
In our Smarty templates, it used to look like this. You can see the hard-coded plural rules and 3 different translations, because the bracket things are how we did markup in templates to mark up strings that need to be translated or replaced with a translated value. And it isn't very nice. So this is what we do now.
This is much better. Here we actually use proper calls to getText functions. We wrote these Smarty functions ourselves, and they do exactly the same as in the previous some examples. Right, so now we've also figured out how to translate stuff and show the right messages, but can we make sure they always show up correctly? For this, we need to consult a character encoding. This is the fun bit. So very briefly, what is a character encoding? A character encoding is a way to represent text. It's a way of mapping bytes or byte sequences to characters like letters, numbers, punctuation, and so on. There are multitudes of available character encodings. Some of the more popular ones include ASCII, which has room for exactly 128 possible characters, which is great when you're designing it for English, not so much for other languages. There's ISO 8859-1, also known as Latin 1, and ISO 8859-15, known as Latin 9, with 256 characters each, designed for Western European languages, doesn't even work in all of Europe. We have Shift-JIS, designed for Japanese, which is actually quite a horrible encoding because it uses special byte sequences to switch code pages within the same encoding. It's a nightmare to work with. And finally, more recently, we have Unicode, our savior, with over 120,000 characters assigned and room for over 1 million. You can use it with any language that's written on this planet, and it has quite a lot of other things as well, including emojis, even some silly ones. So, when you want to use Unicode in your program, it's a good idea to consult UTF-8, especially when you're working in PHP. It's a way of encoding, a character encoding, as it were. It's a way of representing Unicode. It can, the first 128 bytes are fully compatible with ASCII, and the rest of the characters are encoded using sequences of 2 to 4 bytes. It's a very compact text format, especially when you're dealing with Latin alphabet text. And of course, because of its good properties, including being fully supporting Unicode, it has become the de facto standard for text encoding in the PHP and MySQL world, and indeed most of the web.
So, why do we need Unicode? The short answer is the euro sign. Because we were about to open a site in Ireland. Ireland uses euros. Latin 1 doesn't have a euro sign. Latin 9 does, however. As you can see in the table down there, on A4 we have the euro sign in Latin 9, and in Latin 1 it's a currency sign instead, which is also our logo. And our code was a mix of Latin 1, Latin 9, some Windows encodings, and UTF-8. It was a mess, and our database used Latin 1. And we didn't really want to risk ever showing anything else than a euro sign on the Irish site when we were showing prices. So we really needed Latin 9 or something else. And Latin 9 would work, but it won't work if we would open a site in Asia or a Slavic country or anything like that. That's why we want Unicode. In MySQL, there is support for UTF-8, but the thing that MySQL calls UTF-8 isn't UTF-8. It's 6% of Unicode. It's only the basic multilingual plane of Unicode. If you want the full Unicode, you have to use UTF-8 MB4. And if you're using anything else than ASCII letters, your storage requirements will increase. All the Swedish characters like Ö and Ö will use 2 bytes instead of 1 byte. So that's the thing to keep in mind. If you have indexes on text columns, they will be limited to 191 characters if you're using InnoDB. Because there's a limit, I think you can change it somehow, but the default limit is 767 bytes per index. And MySQL will reserve 4 bytes per character when you're using UTF-8 MB4. In PHP, the strings are basically just byte arrays, and the PHP standard string functions are not aware of UTF-8 or Unicode in any way. They are binary safe though, but not Unicode aware. There are multi-byte alternatives available since PHP 4, and they are prefixed with MB underscore. So what would happen if you use the regular string functions with a UTF-8 string?
As it turns out, some things can go slightly wrong. Here we have an example of a lovely Swedish word, one of my favorites, which we're trying to convert to uppercase using the string to upper function. As you can probably see, it doesn't quite do what we intended. The accented characters are still lowercase. That's because string to upper knows nothing about Unicode or UTF-8 or anything like that. You have to use MB string to upper. There we go. And it works as expected. Another example, if you want to split a string, here we're asking PHP to locate the index of the first inside this string here. And it does it just fine, and then we take a substring from that position to the end, and you get part of the string exactly as you would expect. What if you want the string after the You may think that adding +1 will help you there, but in fact it doesn't, because string pos and substring are not very clever. When you say, this question mark here, let me get back to that first. That represents a broken UTF-8 sequence. That means something definitely goes wrong. This happens because the PHP string functions are not very clever, and they actually see 2 bytes for each of the special characters. When you ask it to find the it finds the first occurrence of this here. And when you say +1, it thinks you mean the next byte. The solution again is to use the MB functions, which can actually treat UTF-8 strings as a sequence of real characters. So when you say +1 down here, it means next character, like you actually want. A third example, regular expressions. I don't know how familiar you guys are with regular expressions, but what we're doing here is asking this function to look for any of or inside this string. Since the second string doesn't contain any of these characters, you would expect it not to match. But it does. And there's the question mark again. Something's gone wrong. What's actually happened here is that pregmatch and all the other regular expression functions, they know nothing about Unicode unless you tell them. So they see this. And since we're looking for anything that's inside these brackets within this string, it finds the A with the squiggly thing and matches it, and it returns you just that, which is not valid UTF-8. The solution here is to add the magical U flag, which tells pregmatch and all the other regular expression functions to treat this and this as UTF-8, and then, as you can see, it doesn't match, just like you want. The U flag does have some other consequences. The \W thing, which normally matches only A to Z, now matches everything that is considered a letter by Unicode, whether it's Latin alphabet or Greek or Korean or Arabic. As long as it's a letter, it will be matched by \W. \D behaves similarly, normally matching only 0 to 9. It will now match anything that is considered a decimal digit. Be aware of that if you're using regular expressions. Still, UTF-8 is definitely the way to go. We've known that for a long time. We wanted Unicode. So how did we actually get there?
Well, this was quite a big project for us. I think it was about 6 months we worked on it. So we wanted to break it down as much as possible. There are two main areas, the database and the code. And we wanted to be able to release them independently. And the bulk of the development work was to look at all our code and make sure it worked with both Latin 1 and UTF-8. Then you can set the character encoding on a database connection and read from a UTF-8 database in Latin 1. So we could convert the database first and still read from it as Latin 1 and then convert the code. Now we had to convert all source files as well. They were mixed encoding, Latin 1, Latin 9, UTF-8, Windows 1252, or a lot of different encodings, and we wanted it all to be UTF-8. And in the code, we had to check all usages of regular expressions and string functions to make sure that they were compatible with UTF-8 strings. And we had to check all the places where we sent response headers, both in code and in Apache configs, and things like that, and make it dynamic. It had to read from a config, so we could easily change it from Latin 1 to UTF-8. And again, converting the files to UTF-8 without the byte automark, because that will break stuff. It inserts a special byte sequence at the beginning of the file, and it will be outputted to the browser before your PHP code starts executing, and you can't send headers anymore. And we specified a collation and character set on all database connections and made it read from the config as well. We also added a utility function from UTF-8 that when the site was in Latin 1 mode, it would take a string and UTF-8 decode it. When the site was in UTF-8 mode, it would just return the input string. And we had to create multi-byte versions of a couple of string functions that the PHP doesn't have MB versions of.
So, in order to be able to do this in 2 steps, we had to do a lot of preparation to make sure that everything worked in both UTF-8 and Latin 1 mode. The way we went about this was we created an identical replica of our database, converted that to UTF-8, and then changed our dev machines to alternate between UTF-8 and Latin 1. And there was a very long period of testing, changing, and occasionally altering the database a little bit. all to make sure that everything would work flawlessly when we convert the database, which we did in the next step. This was one extremely long night and part of the next morning as well, where we did as follows. We set the database to read-only mode, because we don't want anyone to mess with it while we're working on it. We dump everything to files, which takes a long time when you have a lot of data, which we do as it happens. We ran some scripts to modify the files, mostly changing database structure, and then we read it all back. This may not seem overly complicated, but it took an awfully long time. Converting the main databases took between 40 minutes and up to almost 3 hours, whereas the log databases took significantly longer, up to 6 hours for an instance that's running on spinning hard drives. As we mentioned before as well, the storage requirements grow quite a lot, and our main Swedish database grew from 160 gigabytes to 195. That's not including log data. After this process, the site is still connecting to the database with a Latin 1 connection, because we haven't touched the code just yet. And the idea was that everything would keep working as normal, and thankfully it did. So it took about 2 weeks to verify that everything was still running the way it was intended. And after that, it was time to convert the files. And you do that by getting me to write a Perl script that goes through every single source file and converts it to UTF-8 if it isn't already. This was a surprisingly painless procedure, but it did result in quite a large git diff, over 9,000 changed lines. And that's just one repository. After this, we could switch the config to UTF-8 and the database connections to UTF-8 and pray that everything worked, and amazingly it did. After this, there was a 2-week period of cleaning up the Latin 1 support, because there's not a chance that we're going back. And of course, when you've completed a large project of this kind, the appropriate response is to celebrate, which we did by going to a beer tasting in Helsingborg. Whew.
So, what did we learn from all of this? What would we do differently if we were to start over? Well, always use a configuration system from the start. Don't hardcode anything into your code. You probably want a different config for development environment anyway, to show exceptions and things like that, which you don't want in production. And use Unicode from the start. UTF-8, it's very good. Just use it. And if you want support for emojis and stuff, use UTF-8 MB4 in MySQL. Otherwise, you can use UTF-8, but your users will probably insert emojis anyway. And set your servers to UTC and then convert it for display. Use a translation system from the start as well. It's very easy to add in the beginning. It's quite hard to add it when you've had a site for a couple of years. And when you're doing translations, don't ever concatenate strings, translation strings with variables and stuff, because word order will vary between languages. And it's just a hassle. So translate entire sentences and inject variables into your translations. In short, don't reinvent the wheel, use existing tools. Don't write your own number formatters or date formatters or anything like that. Use getText or whatever's appropriate in your platform. The Intel package and getText for translations, and you can write your own wrappers around them to make them easy to use, but don't do everything from scratch, because you will miss stuff. There are a lot of things to consider. Thank you very much for listening.